So I've populated a PCB and made up a prototype board. So this is a bit of plywood with the PCB, and I've got wires running out to 0.1 inch headers here. So I've got the programming connector there, I've got a serial port there, and I've got the battery here. So each battery connection I've got a jumper position, so I can connect the battery or disconnect it, and I can also then put current meters on the supply to actually measure what the supply is, because this is going to try and be a low power device, so I need to have some sort of measurement there. The display just goes here and that will fold round eventually. PCB is just held in with screws, just screwed in the edge of the screws over the board. The switches are soldered on and they sort of fit quite nicely there. I don't know what I'm going to do in the final thing. And in the final configuration, the display will be wrapped around like that, so at the moment it's folded out. And making a large scale prototype like this is quite useful in a lot of cases, because trying to work on the final configuration of something like this would be, well, it would be terrible really, if you're trying to get in and look at signals and things when it's in a tiny little case. And here you've got all the signals broken out to a certain extent. Programming on the real PCB will be, I'll solder the wires on, program it, and that'll be it. This will be used to develop code, and then I'll probably make up another board for the final configuration in the case and so on, and that will just be programmed once, or well, maybe up to 5 times depending on how the code goes, but most of the development will be done on this. I'll probably run this off the ST-Link V2 most of the time and not bother with the battery, and that's over here, 3.3 volts. The battery's 3 volts and this should run down to, I think it's 1.8. The display will probably conk out before then, but that's part of finding out how well it works, is running it at lower voltages. And with the jumpers in the supply here, I'm able to do that. I can put a power supply in there and run it off a lower voltage and see when it stops working. So unfortunately the connectors haven't turned up yet, so I'm going to solder that on later on. They should turn up today, coincidentally, and that's not too difficult a job, soldering that on. It's okay, this board. It's not massively small. Some of the components didn't fit too well, but they're on there. So hopefully, well, the processor, that came off a blue pill, so there's one here with no processor on, and that should program. Actually, I should have a go at putting that on there, put some sort of program on and check that it's working. So I've got the ST-Link V2 connected here, and I'll plug that into my computer. So that's now got all 4 wires connected, so you've got ground and supply. So this will be powered from this. This is quite low power, so it should work fine. And clock and I/O are also connected to the appropriate connections on the ST-Link V2. So that's now attached to my computer, and what I've done is just create a blank sketch. So this is the Arduino IDE, and it's just a blank sketch with nothing in it. So all I want to check here is whether the hardware allows the STM here to actually be programmed. So if I build and try and download, you can see that it's actually downloaded, everything's fine, the application's running, and the start operation was achieved successfully. So that has programmed, so it looks like I've got the hardware okay in that respect. Now that's a bit more than just the 4 wires to the processor. It means the power supply is correct. It also means the oscillator's running. Well, maybe. The STM actually falls back to an internal oscillator, but the reset circuit's there, and a few components are wired up okay. So now that I can program it, I can build on this sketch. So we could do some basic checkup of stuff that's going on, but in order to do that I need some sort of output, and I don't have a display at the moment, and there's quite a lot of code needed to get that display to work. So the best option is probably to get the RS-232 working. So I'll have a look, I'll dig around and find one of my serial to USB connectors or adapters, and I'll attach that there, and we'll get the serial debug working as well, because that will be useful when I'm developing stuff in here. So I've got the RS232 adapter here, and I did a quick check. So I went from ground to TX just to check that it is a 3.3 volt device, and it is. So it's USB, not to TTL, but actually to 3.3 volt logic. So what I'm going to do is adjust the sketch just to get some simple output. Now, I normally run with an external editor, so I'm going to swap over and actually do my editing in the IDE. Get rid of those comments. So, if I remember rightly, so I'm going to attempt to just start the serial up and then do a serial message of that. So if I compile that, send it down, the program is still attached, that should program, everything should be fine. What we do need to do, why has that not worked? No, it's asking me to save the sketch. I'll just save that somewhere. Right, so does it build? Yes it does. Has it programmed? Yes it has. But what I do need to do is go in here. So I've already set up the IDE to program an STM32F103. What I need to do is set up for USB serial, so CDC generic serial, supersede UART, USB low full speed and so on, and generic serial. So that's all set up. So this sketch should actually be working. So if I open up the serial monitor, oh, it's running on the wrong port there. So at the moment, oh, actually no, that's wrong. I actually need to have generic serial, but I need to have UART generic serial, so no USB support. And that should be right. So I forgot, I'm actually not using USB, I'm using real serial here, so I'll have another go. I can recompile that and connect up the RS232. Now at this point, if I wired it up wrong, I might be blowing up the STM32, which I don't really want to do, but there's not a lot you can do other than plug it in. So if I now see if I can find a TTL USB 0, which I can now open the serial monitor, and well, there's nothing there. Perhaps we ought to, let's change the code a little bit and put it in the loop so that every 2 seconds it sends that message. Let's download that code. Still attached to the same TTY USB 0. Is it working? No, it's not. So there's something wrong. So what's wrong here? So maybe I've got transmit receive the wrong way around. That's unlikely. What I can do now is I'll probably just stick the scope on there and have a look and see whether there's anything coming out, because that should be working, I think. TTY USB's there. Yeah, so that's probably what I'll do. Obviously I'll need to set the camera up and stuff for that. Okay, so I've found a problem with the serial port. Unfortunately the transmit line and ground were shorted together, so nothing was coming out. So I found that, and I've created a small program which just reads the switch inputs, and it just sets them up as inputs with pull-ups. I haven't got pull-ups on the board, I'm using the internal pull-ups in the chip, so there's no resistors on the board for the switches, they just connect to ground, so you can use the internal pull-up, saves a bit of space on the board. And in the loop it just displays arm watch, and then the two values just reading straight from the input, delays 2 seconds and then repeats. So if I download that, that takes very little space, and it's already down and started. And if we open up the serial port, there we go, So it's displaying the banner and then the two values. So because the switches aren't pulling to 0, they're 1. If I press one of the switch buttons, there we go, one of the switches, and press the other one, and that one's pulled to ground. So that's working fine. So I've got at least transmit on the serial port. I'm pretty sure receive will work as well. I'm not really too bothered by that. What I can do is put a monitor in there if I need to, so you'd be able to interact over the serial port with the code. So the next thing to do is to get the display working. So I'm going to port in to maybe this sketch the by display code. So that's code that's got all the logic for initializing the display. So I'm using the 4-wire SPI here, which means there's data, clock, command data line, and a chip select, and that's all done with the by display code. So I'll do that. It's quite a long job, so I'll just put it in there and see if we can get the display going.